Welcome back to another video. Yesterday we did the sum and difference rules. Today we're going to focus on product, multiplying two functions, and quotient rules, dividing two functions. So, when we are adding two functions, say like 5x plus 4x squared, we could just take the derivative of this one, which would just be 5, okay? The derivative, we say that's y equals, this would be dy dx, equals 5 plus the derivative of this, which would be 8x. It's really simple. We could just go straight down. So a lot of people think that when you're multiplying two functions, you could do the same thing. That's wrong. Don't do it. Alright, so if it was that easy, you guys wouldn't be in calculus. Okay, you'd be back in geometry or pre-calc or something. The correct derivative of a product is in this form here. Now, I like to think of it the other way around. Okay, it doesn't matter which way you do it. You're going to multiply the function by the other derivative, and if you have two functions, you're going to do it twice. The way that I like to think about it, and I repeat this every time I do it, okay, it's the first function times the derivative of the second, whatever that happens to be. Alright, plus the second function times the derivative of the first. And if you just repeat that 100 times, because you're going to do all the worksheet problems, then you'll be just fine, okay, and you'll never forget it. So let's try example 1 here. First, we're going to do it this way, and then we can check by multiplying it out and using the power rule, because we've already mastered that. Okay, so we have g prime of x, our derivative. Okay, it's going to be equal to the first function, 3x minus 2x squared, the first, times the derivative of the second. The derivative is just 5. Okay, plus the second function, 4 plus 5x. Okay, times the derivative of the first, 3 minus 4x. Okay, the derivative is 3 minus 4x. Now we just multiply it out and start simplifying here. So we get 15x minus 10x squared plus, don't forget to multiply binomial here, FOIL if you have to, alright, 12 minus 16x plus 15x minus 20x squared. Combining our like terms here gives us minus 30x squared, and then that would be plus 14x plus 12. Alright, and there is our derivative function. Now if we try it the other way, multiply it out first. Okay, so g of x, we're just multiplying it out, writing it in a different form, equals, it would be 12x, alright, plus 15x squared, so 12x plus 15x squared minus 8x squared and minus 10x cubed. Now if we take the derivative, we're just using the power rule here, 12 times x to the 0, which is just 1, okay, plus 30x squared, or remember we subtract 1 from the power, 30x, minus 16x, and then the last term minus 30x squared. Combine your like terms and you get exactly the same thing. Alright, so I'm just going to do one here on the bottom so you get the idea. You can try the other one and ask questions in class. Alright, let's do this one here. Find the derivative of each of the following. Alright, so to do this, we have the product of two functions. We have to use the product. So it's the first, 5x cubed, times the derivative of the second. Good thing you already memorized that. Anything with the derivative is going to be negative. So we have negative sine of x. Okay, plus the second function now, times the derivative of the first, which would be 15x cubed. And you can combine that or write the negative in the front. You could change the order if you want, or we could just leave it like that. Now you can try this next one all on your own, and at the end, you should get y prime equal to negative 2x sine of x. Okay, that's it. Now, moving forward, we are going to work on the product rule, or the quotient rule. Everybody thinks just take the derivative of the top, derivative of the bottom. Nope, wrong again. Alright, so look at this one. This looks like super exciting. G times f prime of x, blah, blah, blah. Okay, you're never going to remember all of those symbols. So we have to come up with something really fun and exciting for you to remember it. Okay, so we're going to call that top function. That's the high function, right? It's up top. So we'll call that the high function, which I noted down here. And we'll call the bottom the low. Oh, but low's not exciting enough. It won't make a nice song. So we're going to have to call it the ho function. So we're going to take the ho d high quotient rule. Alright, so we can think about it as, if you guys even know who this is, a dyslexic Mr. Wilson. Normally says hi de ho, neighbor. Well, he's going to be saying ho de hi. Alright, minus hi de ho over ho ho. Alright, or maybe the Seven Dwarfs, right? Like ho de hi minus hi de ho ho ho. Okay, or Santa Claus in a Hurry. So try to remember that. Sing a song, it works. Even if you're a terrible singer like me. Alright, so let's try one example with this. So the first part, y prime. Ho d high. Ho, that's the low function. Oh, come on, pen. Oh, try again. Alright. So we have, that's the low function. Ho d high. Remember to keep these in parentheses. Derivative of my top function is 4. Minus high d ho. Right, minus our high function and the derivative of the bottom, so we have 2x all over ho ho. So we have our bottom one squared. Okay, and we can again distribute this, but for the sake of time right now, if that's something that you can do on your own, I just want you to get that practice down. So we will set up one more problem. Okay. Find the equation of the tangent line. Tangent line. As soon as we see that, we know we're talking about a derivative. Okay? Derivative. And we're talking about a specific value at x equals 1. And for a tangent line, we're going to need two things. We're going to need a point and a slope. So while we have a chance, maybe we should just plug it in to get our point here. Alright, 3 minus 1 over 1 is just 1. Over, sorry, I should write this, maybe we're doing f of negative 1. Oh, negative. Good thing I wrote that down. 1 over negative 1, that's negative, so it's going to turn into a positive. And then negative 1 plus 5. So we're getting a value of 4 over 4, which is 1. So we're going to have that point, negative 1, 1. All we're going to need is our slope now. That's the easy part, right? Sure. Alright. Well, look at this function. It's kind of messy. It has fractions. You know, everybody's scared of fractions. Maybe we should just start off by changing it so there are no fractions. And again, we can do that, because we've done it a lot in class. Multiply everything by x. Right? So if we do that, our function now becomes, so we have f of x. Alright, we get 3x minus 1 all over, okay, x squared plus 5x. Now it's not scary anymore. There's no fractions to worry about. Nobody has to cry. Alright, you can rewrite it with a negative exponent, but who wants to do that? Alright, so now we take the derivative, f prime of x. Sing your little song, alright? So, ho de high derivative 3 minus Heidi-ho. You guys should pay me for singing. This is terrible. Alright. Oh, where did it go? There, it's back again. I just can't stand these stupid fish-looking symbols here. It's driving me crazy. Alright. Let's go back to that. See, it fights with me just as much as the smartboard in the class. Alright, ho, d-high, minus high d-ho. So the derivative of the bottom now, because we're really good at the product rule, is 2x plus 5. All over ho-ho. Alright. So, there's our derivative function. Sure, we can multiply it out. Make it look a little bit better, right? Should we? Sure, why not? You have the time. So 3x squared plus 15x. Fish thing, x, whatever. Minus, keeping our parentheses here, 6x squared. Okay. Plus 15x minus 2x, or 2 fish thing, minus 5. All over again, x squared plus 5x. Oh, I think it's good enough. I think I'm ready to plug in that point. Okay, x equals -1, because I need to find the slope at that point. So 3 times -1 squared, which is just +1, plus 15 times -1. Alright, minus, that's going to be 6 minus 15 plus 2 minus 5 all over the bottom part. Alright. Okay, so I should really worry about the bottom part, but I'm not, because I can see into the future, and I see that when you start to simplify this, you get 0 in the top, and you won't get 0 in the denominator. So, because of that, our slope is 0. And we're going through the point now, -1, 1. So if our slope is 0, we're going to have y minus y1 equals m, or that's our 0, right, times x, minus the -1. And we should know, since the slope is 0, it's just simply, if we simplify it, going to be y equals 1. There's the equation of our tangent line. Alright, so I have one more quick thing to talk about. There are lots of ways to do the problems. So first, you just need to focus on being able to do the product rule, being able to do the quotient rule, being able to work through the power rule. Alright, but then once you start to get really good at it, you can be more efficient. So if we take a look at this, I could use the quotient rule. It's a fraction, or I could possibly rewrite it, because now I could just break it down into 2 separate parts. 1/6 x squared minus 1/2 x. I think that's easier for me to just do the power rule. Alright, so 2 times 1/6, we're talking about y prime here, would be 1/3. Oh, okay, y prime equals 1/3 x minus 1/2. Done. I think that's a lot easier than trying to do the quotient rule. Alright, same thing here. That's just simply y equals 5/8 x to the 4th. I wouldn't do the quotient rule there. Alright, so 4 times 5/8 is going to give us 5/2. So y prime, in this case, equals 5/2 x to the 3rd. Alright, and you guys go ahead and do these ones. So maybe, just maybe, it would be quicker to multiply this out first than it would be to do the product rule. But that's something that you get with practice. So that's what I need you guys to do, is just practice. Alright, so thanks. Try a couple of problems on the worksheet. Come in with questions tomorrow. Let me know anything that you didn't quite understand. Alright, have a good weekend. Goodbye.